So, now see velocity of sound in gases is affected by different factors. So, now we have seen the formula for the velocity of sound in gases, that is V is equal to under root of gamma p upon rho. This is your pressure and this is rho is density. Now, we know it here velocity is inversely proportional to under root of density. Now, we can simplify it. This is the first factor we have got, velocity is inversely proportional to under root of density. We can take another factor also. If we write velocity is equal to under root of gamma p upon rho, can be written mass upon volume here V. So, I have written rho is equal to mass upon volume, here velocity for writing this here V in this manner. Now, see here, if temperature is constant, if T is constant, then PV is constant. It means velocity is actually independent of pressure provided temperature remains constant. So, this is here it does not depend on the pressure if temperature remains constant. So, another factor also we can see from here, if we have got this velocity is equal to under root of gamma PV upon here m, we know PV is equal to nRT, that is RT we can write gamma here RT divided by m. Rest everything is constant here. So, velocity is directly proportional to under root of temperature. See here velocity of sound depend on the density also. So, density of the air changes with the humidity. So, here we can write here density of the moist air is less than density of the dry air. So, obviously, the velocity in the sound in the moist air will be greater than the velocity of the sound in dry air. So, that due to humidity also velocity of sound is getting affected.